Good morning, Swivel. All right, let's start all over. Let's pretend we didn't talk about all this. All right. This is a continuation of. Okay. All right. Now let's move on. Tough crowd today. All right. Let's go to page 118. That's what I want to do. I fast forwarded. Okay. We have to remember things called slope. Do you guys remember slope? Slope. Have we talked about it yet? Yes. We talked about it in chapter 4 and yesterday. The slope is change in y over change in x. Oh, you guys are great. Do you remember how I can also write it? Do you remember that other special way with instead of delta y over delta x? Good. And then the other way you can look at it, well, and there are actually other ways, more than one way, but the other way you can look at it is, sorry, I'm trying to think which way I want to talk about. Rise over run. That's what I want to get, rise over run. How many of you kind of remember this? Like it's somewhat, okay, rise over run? Okay. These ratios are all the same thing. So if you ever see change of y over change of x, you can think rise over run. And then we'll look at a fourth way of looking at it. Okay, so what I'm going to do here is I'm going to draw a line. I'm going to draw a graph. So this one has to be a little more accurate. Let's go 5 out each way. I feel like I just did this with you guys. Do you guys remember this? No? That's okay. Maybe it was with last year's 8th graders, but I feel like, didn't I do these tick marks? And then do the graph. Okay, so it's I call it a 5 by 5. It's technically a 10 by 10, or I guess 11 by 11, but like 5 by 5 just means it goes out 5 every direction. All right, real quick, plot these points on that graph. 2, 2, 2, 2. 2, 2. 4, 1. 4, 1. 4, 1. And 0, 3. 0, 3. The bigger I make the dots, the more they fit. Okay, and then negative 2, 4. Negative 2, 4. Negative 2, positive 4. Okay. Now, is that a relation? Yes. Is it a function? Yes. Is it a linear function?
Not yet.
Not yet. Good, good. So you guys remember that now. Is it a linear function? Okay, now it's a linear function. And it's a function because it passed that vertical line test. It's linear because it's a line. And how many points does a line have? Infinite. How many did I put? Like how many did I explicitly put? 4. But there are still other ones. Like there are points all over here. And their coordinates are decimals and fractions. And that's okay. Okay. What I want you to do here is I want you to see if you can find the change in y over the change in x. All right, what's the y-axis? Is it the vertical or is it the horizontal? Vertical. Don't forget that, guys. That's going to help you out overall in a lot of different things. So here's my y-axis. Okay, pick any one point. And see, I'm going to do this a little bit more generally. Pick any point. So pick one of the 4. Okay, just pick it and just maybe point to it for your own good. Point to it. Okay. I'm gonna pick this one. How many of you picked this one? Okay. Wow. How many of you picked that one? Oh, this one? Yeah. That one? Okay, so the least popular. Wow. Okay. I picked this one, I think. I think that's what I picked. Now, what I want you to do is I want you to see from this point that you picked to the next point, how much did you change in your y-axis? So from this point right here to this next point on the right that we labeled, how much did I change on the y-axis, so vertically? How much did I change? Okay, I heard someone say it properly. You changed -1. You went down 1, didn't you? You went down 1. Okay? So I'm going to do this. You're changing y is -1. Okay. How much did you change on your x-axis? From the point on the left to the point on the right? 2. Okay, so you went 1, 2. You went +2. All right, that's your change in x. What is your slope?
-1/2.
Okay, -1/2. Remember how we talked about this yesterday? It could be +1 over -2, or it could be -1/2. That's probably the most natural way. But both of these are correct. Both of them are correct. As even that one right there. Okay, now listen. Who picked this one? Could you go more to the, I mean, like from our diagram, could you go more to the right?
Yeah.
I mean, you could, right? Did it go down 1 over 2? Okay, now here's what I want you to do. Everyone, pick the same point you have. Now I want you to see what's the vertical change when you go from that point to the one on the left. So here I picked this one. I'm going to see from here to here. So from here to here, what was my change? All right, what was my change? +1, wasn't it? Wasn't it up 1 if I'm going to the left? And then what's my change to the from this point to this point on the x-axis? -2. So doesn't it look like this? Okay, it's the same thing. I got this, I got that, but they're both the same thing. All right. Poor little point over here. Sad little point. No one picked. I don't think anyone picked him, right? Did you pick him, Dylan? Jack Angel? Okay, ready? We're going to pick him because we don't want to leave anyone behind. All right, let's pick this point, guys. Let's pick this point, and let's pick that point. Do you guys see what I'm doing?
Yes.
Okay, ready? What's the change in y from this point to that point? 1, 2, 3. Negative, right? -3. What's the change in the x-axis from this point to that point? 1, 2, 3, 4, 5, 6. And it's positive, right? Oh, man. Oh, if I simplify, what do I get? -1/2. It doesn't matter what points you pick, you're always going to get that same slope. Do you understand that? The slope, guys, is a rate of change, a ratio of change. This is one of the big keys to that graph. It has a slope of -1/2. Okay, do you guys remember anything about negative slopes? Do you guys remember what we mean by negative slopes? What does it mean? Read the graph from left to right. So from left to right, what is the graph doing?
Going down.
It's going down. You know why? Because it has a negative slope. What happens if it was +1/2? What would happen? Left to right, it would go up. And that is Jack Hart. I know you're right, which is good. But I have a question for you. If I give you the slope and it's positive, I don't care what the numbers are, from left to right, what does it have to do?
It's on.
It has to go up. Please, I'm begging you just. If it's a negative slope, it has to do what from left to right? Michelle, I don't ever want to see your paper show me -1/4, -10, and it do this. Do you understand me? Will this be the first year where every student, even if you got the wrong slope, but your graph matches what you said, will it be the first year? First year. That everyone is consistent with that. Gracie, positive slope does what from left to right? It goes up. Do you understand that, Hagen? I'm looking at Hagen. I'm not saying anything, Hagen. You too, Olivia. You're not out of this, Matthew. I want positive goes up, negative goes. It has to do that. Please don't disappoint me ever again. Okay, anyway. Let's see who is paying attention. Ellie, were you paying attention? Just, yeah, say yes. Yeah, don't listen to Philip. Like, do the opposite of what Philip told you to do. And you'll be safe. Okay. All right, just sketch these out real quick. And Ellie's going to give you this answer. Ready? Okay, Ellie, positive or negative slope?
Positive.
That's a sloppy S, but that's a positive slope. All right, now we're going to go with Nelson. Okay.
Negative.
Okay, now, yeah.
If you did it perfectly.
Okay, Nelson. Let's pretend it was perfectly horizontal. Sorry?
Positive. Neutral.
Close. Okay,
No. 0, 0, no solution? Or
you get there. No, I didn't help. This is hard because I never talked about it. You know what your slope is on this one?
0 slope.
Oh, yeah.
Do you remember this? Wait, draw that out. Do you remember this? What was the slope of this horizontal line?
0.
What was the slope? And you're like, wait, how'd you know? That's the slope. That's the slope right there. Okay, Alex. That's a vertical line.
0 slope?
No, it says it in the book, Alex.
What the?
That's cheating.
Yeah, who does that?
Undefined slope.
Undefined.
Oh, undefined. Another way to say undefined, like practically speaking, it doesn't have a slope. It doesn't have a slope. And mathematically, we'll see it later on, but undefined's a good word. It doesn't have a slope. You're like, wait, isn't it super steep? Not really. It's like, I can't even describe the steepness of a vertical line. I can describe that. That's 0. It has no steepness. 0 steepness. But I can't define a vertical line slope. All right. What's the other one? I'm going to erase this, but obviously you have this in your notes already. Recycle stuff. So which one's this? Negative. Slope. Don't break my heart. Guys, I think you guys, out of all the classes I've had so far, are capable of being consistent, but I don't know. I'll have to see on that first homework and first quiz, like, can they do it? Can these guys be it? Are these the chosen 8th graders? Yes.
what if it's like curvy or loopy?
Great question. Like just like, well, it's no longer a linear function, so we can't talk about one slope. It has many slopes or an infinite number of slopes, aka a circle. Circle. Because it's made out of, yeah, it's too complicated. Tangent lines, da-da-da-da-da-da. So yeah, it's not gonna. Okay, anyway, let's move on here. Yeah, I wish. Let's go with the slope formula. All right, the slope formula. So the slope formula, oh man, this is so cool, guys. Remember our sequences? You remember how to find an arithmetic sequence? You would take the second term and subtract the first term. Do you remember doing that? To find like you had 1, 3, so you do 3 minus 1 would get you that common difference. You remember that? Okay, it's the same thing with the slope formula, and here it is. I'm going to put it M. What does M stand for again? M is for Michelle. And for monkey, and for others, mom, because I read these books still. M is for monkey, M is for mom, M is for math.
No.
Matthew as well.
M is for Malou.
M stands for slope. Okay, so whenever you see M, you think slope. I'll put that in parentheses. All right.
N is also for Malou.
Yeah, because S is like it's, oh man. It's its own variable. Like it's used for other things. So
Is it M?
I think
Yeah.
I think M stands for Maleficent, which is the mistress of evil. Or different math of evil.
all right, here it goes. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's it. That's the formula. That's when you don't even have the graph. They don't even give you the graph. All they give you is 2 points, 2 ordered pairs, and you can find the slope. That's all you need. Okay, so here is a set of ordered pairs. 3, 5. So let's use 3, 5. That's 1 point. And then the other one's going to be -1, -1. Okay, so they give you these 2 points, and they're like, all right, these 2 points are on the line. Find the slope. You're like, how many points are on the line? Infinite, and they just gave you 2. That's all you needed. Any 2 points on that line can figure this out. But I'm going to use those 2 points to find this slope. So here's what I'm going to get. What's y sub 2 and y sub 1 stand for? Well, here, let me label some things. How many x values are up here? 2 of them, right? So do you understand that we can't just call them both x? I'm going to call one of them x sub 1, and I'm going to call one of them x sub 2. I hope that makes sense. If I call them both x, I'm like, put in x. And you're like, which one? Well, the first one. Yeah, but could you switch these points up? Could you technically switch the points up? Do this. Yeah, so you just got to label them. You got to keep them in your mind. What's this one called, do you think? Y sub 1, and therefore this one's y sub 2. All right, so we have our key to what the numbers are. So y sub 2 is -1. Y sub 1 is 5. So here's my problem. -1 minus 5. -1 minus 5 over, what's x sub 2? -1 again, minus x sub 1. And then you work that out. What's -1 minus 5? -6. What's -1 minus 3? -4. Is that my final complete simplified answer? No. And I think Will had this question. He's gone. But he's gone for now. Oh, wow. Okay, gone from the school right now. Okay, not that way. He's on, where is he?
He's in a better place now.
He's in a better place.
Okay. Anyway, what's a negative over a negative?
Positive.
So my answer is going to be positive, and I'm going to leave it as an improper fraction, 3/2. That's my slope. Drew? Tell me how this graph should look.
It should be a positive.
Good. It's positive, something like that. And you're like, well, is it like that? Is it more like that? Is it like that? I mean, where is it there? You can give it shape once you look at it on the actual graph when you put it on the coordinate plane. But here I'm just going to sketch it for some of you who want to know. -1, -1, and 3, 5. So it looks something like that. So how steep how would you describe the steepness?
Pretty steep.
Pretty steep, not extremely, but it is relatively steep. And we say, if you ran up of it or you went down it the opposite way, that'd be steep. But I would say this. We talk about relative. Like, have you ever heard of like relative theory, general relativity? That really means it's based on your perspective. Like some of you are like, that's not so steep if I'm like rolling down, I don't know, a ball down it. But if I'm going down it, yeah. If I'm going down with a car, it's not, that would be awful for a car. But anyway, it just depends on your viewpoint. It's relative. So we say it's relatively steep. Okay. I think you're done. You're done with me talking, but I don't know about your work. Okay, let me give you...
Now for the recording of me talking.
I will listen to myself later.
Do you ever go back and watch your video?
I actually did with my wife, and that was...
Laughing the entire time.
Oh no, I'll tell you real quick. 2 through 22 even.
You're fall break.
I'll take your break.
Sorry?
Fall break.
Oh, you guys are on fall break?
Yeah.
Oh. So you have plenty of time to get it done.
Yeah, but what's going on?
Get some done now. Bye-bye, Swivel.